All right, so let's jump right in. We're going to talk about something that's, well, it's the stuff of nightmares for a lot of engineers, right? We're talking about those critical batch jobs. But more than that, we're asking, how do you build them so they don't just survive a cloud outage, but can actually thrive by running across multiple clouds? It's all about designing for true, bulletproof resilience.
So, here's how we're going to break it down. First, we'll start with that dreaded 3 a.m. pager alert. Yeah, you know the one. Then, we'll look at a real-world example, the nightly job. From there, we'll get into the 3 pillars of a solid design, see how it all comes together when things go wrong, and finally, talk about why this multi-cloud strategy is such a game changer.
Okay, picture this. It's 3 a.m., the world is quiet, and then your pager goes off. We've all been there, right? That heart-stopping jolt in the middle of the night. It's the classic textbook problem of putting all your eggs in one basket. Or, in our world, trusting everything to a single cloud.
So you fumble for your phone, eyes barely open, and there it is. An angry email, or worse, a Slack message from your boss. Where's the report? And not just any report, right? This is the critical daily report, the one the whole business uses to make decisions first thing in the morning. And it's just gone. The first and only question on your mind is, what happened?
And the answer, when you dig into it, is almost always painfully simple. The nightly job, the one that crunches all that important data, it just failed, hit a snag. And because it's only running in one spot, a single point of failure in that one environment took the whole thing down. Ouch.
Okay, so enough about the problem. We all know it's bad. Let's talk about the solution. And to make this super concrete, we're going to stick with this exact scenario, that critical nightly data job. Think of it as our case study, our blueprint for how to build something way, way better.
So, for the rest of this, I want you to imagine you're the senior architect on this. This problem has landed on your desk. The mandate from on high is crystal clear. This can never, ever happen again. The business absolutely needs a system that can take a punch and just keep on running no matter what.
So your design really boils down to 2 main goals. The first one is resiliency. Failover. If Cloud A has a bad day, the job has to automatically hop over to Cloud B and keep going. Simple as that. The second goal is capacity, or what we often call bursting. You need to be able to spin up more resources, maybe across multiple clouds, if you suddenly get a massive amount of data to process.
Okay, so how do we actually do this? Well, the cool thing is, you can break this whole complex problem down into 3 really simple, fundamental pillars. And if you get these 3 things right, that's the secret sauce. That's the key to unlocking a truly rock-solid, multi-cloud setup.
And what are they? They are, number 1, scheduling. That's the where and when. Number 2 is data access, making sure the job can actually get to its data. And number 3 is failure handling, the automated safety net. So let's dive into each one of these. All right, pillar number 1, scheduling. The best way to think about the scheduler is like the air traffic controller, or maybe the brain of the whole operation. It's the piece that knows what's going on everywhere. It knows the health of Cloud A, Cloud B, Cloud C, and it's its job to make the smart call. Okay, everything looks good, let's run in Cloud A. Or, just as importantly, whoa, there's a problem over there, let's pivot and run this thing in Cloud B instead. Okay, pillar 2, data access. Now, this one is so important. I can't stress this enough. Your job is only as mobile as its data. Think about it. If your code can run in Cloud B, but all its data is locked away in a database in Cloud A, well, you can't actually fail over, can you? So the whole game here is to decouple your compute from your storage. Make it so your job can get the data it needs no matter where it's running. And that brings us to our third and final pillar, failure handling. And look, the most important word on this slide is automated. A truly resilient system doesn't need you to wake up at 3 a.m. to fix it. It has its own built-in sensors, its own nervous system, to detect that something went wrong. And once it detects a failure, it automatically kicks the scheduler into gear to do something about it. Like, say, rerunning the job in a place that's actually working. All right, so we've got our 3 pillars: scheduling, data access, and failure handling. Now, let's see them in action. Let's play out a real-world failure and see how these pieces work together to make sure that report actually gets delivered. And this is just beautiful when it works. Check out the flow. Step 1. A failure is detected in Cloud A. That's our failure handling pillar doing its job. Step 2, it instantly tells the scheduler, hey, we got a problem. And the scheduler, our brain, redirects the job over to the healthy Cloud B. And then step 3, because we have our data access sorted out, the job just starts up in Cloud B and keeps going. The best part? Your stakeholders, the business, they might not even notice anything happened. The report just shows up. That's the goal.
So you might be thinking, okay, that sounds like a lot of work. And it is. So what's the big payoff? Why go through all this trouble? Let's quickly sum up the massive advantages you get with this design compared to just sticking with one cloud.
I mean, this table really lays it all out, doesn't it? If you stick with a single cloud, you're living with high risk. It's just a fact. And your capacity is capped by whatever that one provider has. But when you go multi-cloud, using the design we just walked through, your resiliency is way higher, and your capacity becomes super flexible. You're no longer limited to just one playground.
So if there's one thing you take away from all this, let it be this. It's all about a mindset shift. You have to stop hoping for the best and start designing for the worst. Great architecture isn't about preventing failure. That's impossible. It's about accepting that failure is inevitable and building systems that just don't care when it happens.
So I'll leave you with this question. Your workload will fail. It's not a matter of if, it's just a matter of when. So the real question you got to ask yourself is, when it does, is your architecture ready?